Good morning. Good morning and welcome to NLA Technical Webinar. Sorry, I am first Sukhpai Boon, Head of Program at NLA. Today, Airflow will share with us on the importance of residential ventilation. In this session, we'll focus on some of the key drivers, including the new 2022 building regulations, compliance guides, and approved document F, including all the ventilation system available to be installed in the home. This will also cover ventilation and heat recovery, which improve the energy efficiency of any home. Also, we will look at the installation and best practice, the do's and don'ts. This event is part of the Don't Move, Improve program, and I would like to thank our program champions, Airflow, Schuko, SMEC, and Vitra, to remind you again that there will be a chance to ask questions at the end. So please send questions using the Q&A button on Zoom. So now I would like to introduce Ian Palmer, Head of UK Specification at Airflow. Over to you, Ian.
Thanks, first. Good morning, everybody. I'm just going to share my screen. Okay, hopefully you can all see that. So yeah, good morning. The CPD today is all about understanding UK building regulations relating to residential MVHR. Just to give you all a quick brief background on Airflow developments. We started up in 1955 in a small factory in High Wycombe, where we manufactured airflow measurement devices. Airflow is still based in High Wycombe today, and we now have subsidiaries over in Germany and Czech Republic. Some of the range includes the domestic extract fans for both your bathrooms, kitchens, wet room areas, domestic MVHR, which is our main focus today. We also do whole house extract, intermittent and continuous extract fans, as well as the residential ducting systems. And on the commercial side, we do larger commercial heat recovery units, air handling units, industrial flue dilution fans. So today's presentation, we're going to focus on residential MVHR. The course today is going to cover why we need ventilation, the effects of poor ventilation, different house build types and their results. Of course, the residential building regulations. This includes Part F, Part L, and O. The Domestic Building Services Compliance Guide, ERP, the Energy Related Products Directive, SAP, which is the Standard Assessment Procedure, PAS, which is the publicly available specification, Passive House. Then we'll talk more about heat recovery itself, go into ducting, the do's and don'ts, and finish with on-site measurement and building control. So if we begin with why we need ventilation, number one is to provide fresh air into the building. Two is to dilute the airborne pollutants which are built up inside the building itself via the occupants, the fabrics of the building. Three, we need to control excess humidity in the wet room areas to avoid mold growth. And four, providing air for fuel burning appliances. So these are some of the main reasons why we need ventilation in any building, really. So with the dilution of airborne pollutants, there's a number of pollutants that can be found in the home, and some of the most common pollutants are CO2, odor, volatile organic compounds, VOCs, and particulate matter. So it's very important that we extract these pollutants from the space and dilute them by supplying fresh air into the building. Controlling excess humidity is important, especially in the wet room areas, because condensation forms when the temperature of the surface is below the dew point of the surrounding air. And you can see by the images, this leads to steaming windows, walls, and ultimately mold growth. And then if you have mold in the home, it can cause issues with the occupants, such as asthma, allergies, and skin disorders. Providing air for your fuel burning appliances. So where you've got flueless gas appliances installed, ventilation is required to safeguard against the dangers of incomplete combustion. So a mechanical ventilation system may be needed to provide this. Because of the high ventilation rates that are needed, preheating of the ventilation air should also be considered. So this is where heat recovery comes in as the most cost-effective way of doing this. And you can also add in CO or O2 detectors these can be then considered to warn the occupants of the dangers of incomplete combustion. So going on to the way houses are built. So the characteristics of a typical old style home, Victorian house, it would rarely suffer from indoor pollution problems because it's such a leaky house. So, you know, they may just have single glazed windows. The insulation might not be as it is today. So there's a lot of natural air movement through the building. Open fireplaces, bare floorboards, air bricks as well. So they've got a lot of natural ventilation going into these spaces. Others will say that these buildings are drafty, but of course, draft means that there is supply air and fresh air coming into the building. And then if you compare that to the sort of new build properties in today's world, so these are a lot more airtight. They will have double or even triple glazed windows and doors. Very rarely you now see air bricks on new builds, if at all. They'll be fully carpeted. So there is very, very little air naturally going in and out of these buildings. So in a way, that because they're so airtight, you need another form of ventilation in these buildings to allow that. So yeah, although the new homes will be nice and cozy, very warm, no drafts, the problem is it's almost like the house is in a bubble, in a sealed bubble, or plastic bag, as we reference here. And then the problem with that is you've not naturally got any dilution of these airborne pollutants, because you've got very little airflow going through the homes. This is assuming you haven't got mechanical ventilation. And because of the air tightness, it leads to poor indoor air quality. And this can lead to toxic home syndrome, which is linked to over 40,000 deaths a year. Occupants, they can develop, again, allergies, asthmas, all types of issues. And you see by the stat there, 15.3 million UK homes are at risk of toxic home syndrome, build-up of a number of airborne pollutants, including the CO2s and VOCs. So moving on to the building regulations. So these are the new regulations that will be coming into effect in June this year. We have Part F. Volume 1 is related to dwellings. Volume 2, which isn't mentioned here, is for non-dwellings, commercial buildings. In the middle here, we've got L1A, L1B, and the Domestic Building Services Compliance Guide. So these refer to the older regulations, and over to the right we've got Part O, which is a brand new regulation all to do with overheating mitigation. So now these three documents in the middle, L1A, L1B, and the Domestic Building Services Compliance Guide, all form one document, Part L. So the building regulations have slightly been simplified to make it easier to read and understand. And part L again comes in 2 volumes. So part L, volume 1, refers to dwellings and is all relevant to dwellings. And it's all about the conservation of fuel and power. And part L, volume 2, covers all of the non-domestic buildings, commercial buildings. So part F, all to do with ventilation. It's just to give you a brief breakdown of the document. Section 1 is all to do with the introduction. Section 0. Section 1 is ventilation provision. Section 2, minimizing the ingress of external pollutants. Section 3, work on existing dwellings. Section 4, commissioning and providing information. And then towards the end, we've got the appendix A to F. Some of the recognized mechanical ventilation systems that part F refers to include natural ventilation, which is actually also intermittent extract ventilation, or IEV, continuous central mechanical extract ventilation, which is CMEV, decentralized mechanical extract ventilation, DMEV, and mechanical ventilation with heat recovery, MVHR. So with IEV, you've got in the image there, you've got intermittent extract fans in the wet rooms, and then you have the natural ventilation coming in through the windows or through the trickle vents. Continuous central mechanical extract ventilation, you would have a single extract unit shown there in the loft space, extracting again from the wet rooms, and then you've got natural sort of window ventilation for the supply. Decentralized mechanical extract looks very similar to natural ventilation with intermittent. The only difference is that these fans run continuously. So whereas intermittent is on and off, these fans run continuously. Finally, at the end there, you got mechanical ventilation with heat recovery. So this will do the full supply and extract of the entire building, and the system does not need to rely on trickle vents or opening windows and doors. So staying with part F, in section 1, there is one of the first relevant tables when you're sizing mechanical ventilation for your dwelling. So this table 1.1 lists the minimum extract ventilation rates for intermittent extract fans or extract systems. Some slight changes here to the old regulations. The kitchens used to be 30 litres a second when they were adjacent to the hob, and 60 litres a second elsewhere. And now they show 30 litres a second when a cooker hood is extracting to outside, and 60 litres a second when there's no cooker hood or the cooker hood does not extract to the outside, so where it may be a recirculating hood. The following table 1.2 shows minimum extract ventilation rates for continuous extract systems. So these extract rates are a lot lower, but because the extract is in continuous mode, they can meet these lower standards. So remember, these are the minimum standards. So you can have a fan doing a higher rate, which would be better, but as long as it meets the minimum standards, it's complying with the building regulations. And this is the installed performance as well, by the way. Table 1.3, this shows the minimum whole dwelling ventilation rate determined by the number of bedrooms. So to the right of this slide, you can see what the previous rates were. So for example, a 1 bed the minimum rate used to be 13 litres a second, it's now 19. And you'll see each one is increased, even going up to the 5-bedroom property, a 5-bed. The minimum ventilation rate used to be 29 litres a second, it's now 43. So these are quite significant changes because this will increase the size of your ventilation unit and your ventilation system. Staying with part F and on to purge ventilation, also in section 1. So there's some detail on purge, and it states the minimum purge extract rate of 4 air changes an hour when being used to remove excess heat which is in line with Part O. So already a reference to the brand new regulations, Part O in Part F. And Part O is overheating. So this says that the floor area may need to be taken into account as the higher of the two calculations should be followed. Still on Part F, and skipping right through now to the appendix, there's a completion checklist and commissioning sheet right at the end. And so it gives all commissioning details, and these details, they must on this sheet, they must detail the fan performance, so the airflow rates in litres a second, and this is the installed performance which must be measured. So although manufacturers will put the performance of the fan on their data sheets, this could differ from the installed performance, because a lot of the time the performance of these fans are measured just for a wall. So if you're adding then ducting onto the system, this adds pressure, and that installed performance could be affected. And at the end, this document must then be handed over to the homeowner. So all homeowners must be given a document that shows their ventilation rates in their home. Moving on to Part L, so the conservation of fuel and power. So relevant sections here with regards to ventilation is section 4, which covers limiting heat gains and losses, insulation, thermal bridging and air tightness. Section 5, which is minimum building services efficiencies and controls, general guidance. Section 6, which is system specific guidance on mechanical ventilation. Section 7, which is air permeability and pressure testing. Section 8 on commissioning, and Section 9 providing information. So going to Section 4, limiting heat gains and losses and air tightness, and going straight to Table 4.1, this covers the air permeability in new dwellings. And then to Section 6, all about the system-specific guidance and focusing on mechanical ventilation. Details the maximum specific fan powers. So you'll see there the intermittent extract 0.5 watts per litres per second, continuous extract 0.7, continuous supply 0.5, and MVHR 1.5 watts per litres per second. Staying with Part L, going on to Section 9, providing information. So additional information for new dwellings. So this is a brand new user guide, which is now a requirement to be supplied to all the homeowners. It's called the Home User Guide. That's what the regulations have called it. And the guide should contain advice on ventilation. Airflow's manufacturers of ventilation units, we have produced our own home owner manual for ventilation and for the ventilation systems, because as you saw from my earlier slide, there is the 4 main types of ventilation systems that are available, and the homeowner needs to understand which ventilation system they actually have in their home. There's a link there as well to the government website where you can download the Home User Guide template. So that these sections on Part L1A, so Part 1L, L1A is now included in Part L, so it's just the one document. And parts of L1A, there's sections on the requirements, demonstrating compliance, design standards. This includes CO2 emission rates. Section 3 is quality of construction commissioning, thermal bridging, air permeability and pressure testing. Section 4 is providing information. 5 is model designs, and then you've got Appendix A to E. In Section 2 in L1A, inside Part L, it covers design standards and the criterion 3, limiting the effects of heat gains in the summer. So there's a note here: if a balanced mechanical ventilation system is installed ensure a summer bypass function is used during the summer, the ventilation then becomes more effective in reducing overheating. And section 4, providing information. So again, this is referring back to one of the previous slides where we're providing more information to the homeowner on their ventilation system. So the owner of the dwelling should be provided with sufficient information about the building, the fixed building services and their maintenance requirements. And it should also explain how to operate, control and maintain their ventilation system. Part L1B, which is also included in Part L now, relevant sections on introduction, the requirements, general guidance, guidance relating to building work, guidance on the thermal elements, consequential improvements to energy performance, and again, providing information. And section 4 specifically, guidance relating to building work. So this is for existing dwellings and controlled services, commissioning of fixed building services. There's a recommendation to follow the guidance in the Domestic Building Services Compliance Guide with regards to the mechanical ventilation system. Part O. So part O is the overheating mitigation. So the sections here: introduction, simplified method, dynamic thermal modeling, ensuring the overheating mitigation strategy is usable, and providing information. So section 1, which is the simplified method, categorizing residential buildings. It talks about cross ventilation, and cross ventilation is the ability to ventilate using openings on opposite facades of a dwelling. Having openings on facades that are not opposite is not allowing cross ventilation, e.g. in a corner flat. Section 2 is all about dynamic thermal modeling and removing excess heat. So excess heat should be removed from the residential building by any of the following means: opening windows. So the effectiveness of this method is improved by cross ventilation, ventilation louvers in external walls, a mechanical ventilation system, or a mechanical cooling system. In Appendix C on Part O, it lists areas with a high risk of its buildings overheating. So table C1 and diagram C1, they include postcodes areas in London that are classed as high risk of overheating. And you see also there's central Manchester postcodes, which are also listed as at risk of overheating. Domestic Building Services Compliance Guide, which is now also included in approved document L. The relevant sections here regarding the ventilation were section 1, where it covers the European directives, ERP, which is the Eco Design Directive or Energy Related Products Directive, Energy Efficiency Directive, and Energy Performance of Buildings Directive. And section 8, mechanical ventilation, where it talks about the scope of guidance, energy efficiency of mechanical ventilation systems. So section 8, where it's on covering mechanical ventilation, this touches on intermittent extract, continuous supply, and continuous supply and extract with heat recovery. And the table 34 highlights recommended minimum standards. So again, because it's now in Part L, it does refer to the specific fan powers, which we touched on earlier. But it also focused on minimum heat recovery efficiency. So if you're using an MVHR system, the minimum efficiency needs to be 70% or higher. And it also covers the controls, says that these mechanical ventilation systems, they may be manually controlled or automatic. So we mentioned ERP, Energy Related Products Directive. So this is a directive that all products have to meet, specifically ventilation products here. So the ventilation products, this is an example of the documents required with an MVHR system. So Airflow have used an example of our Adroit system here. You've got the energy labeling and the product fiche on the left. You see the energy labeling down at the bottom there as well. So this is all needs to be supplied when a ventilation system is being installed. Moving on to SAP, which is the Standard Assessment Procedure. So this is the government standard assessment procedure for energy rating of dwellings. Relevant sections here regarding ventilation is section 2, where it covers the ventilation rate, mechanical ventilation, and then appendix L, which is energy for lighting and electrical appliances, and L2, which is specifically electrical appliances. Table 4G talks about the specific fan power for mechanical ventilation systems, and heat recovery efficiency for MVHR, and table 4H use factors for mechanical ventilation systems. Staying with SAP, the Standard Assessment Procedure, there is a database, Appendix Q database, online, so you can search specifically for the PCDB number, which is the product characteristics database. So if you're looking to use a specific product, mechanical ventilation unit, you can choose to search a database for PCDB, select mechanical ventilation, select your balanced whole house mechanical ventilation with heat recovery, and you can choose the brand name and the MVHR model, and you'll see the screenshot there of an example of an MVHR unit where you can get the numbers straight away and you can get all the SAP performance data. There's also a link here to the database. Going on to PAS, which is the publicly available specification 2030 and 2035. So this is all about retrofitting dwellings for improved energy efficiency, and there's a specification and guidance. So the relevant sections with regards to ventilation in this document is Annex C, normative, which details the requirements for provision of adequate ventilation, and existing ventilation says, if any, must be assessed. So the ventilation must be adequate following any additional energy efficient measures. Passive house. So passive house got two spellings there. So we've got the British spelling and we've got the European spelling. Passive house is a building for which thermal comfort can be achieved solely by post-heating or post-cooling of the fresh air mass, which is required to achieve sufficient indoor air quality conditions without the need for additional recirculation of air. Typically in the UK, to achieve passive house standard, you need to have superior levels of insulation, high performance windows with insulated frames, airtight building fabric, thermal bridge-free construction, and very importantly, an MVHR system, so a mechanical ventilation system with highly efficient heat recovery. And if you are putting an MVHR system in because you need to meet the passive house standard, you can't meet the passive house standard without MVHR. The MVHR system itself must also come with its own passive house certificate. So if you see an MVHR unit with passive house certification, you can find it on the Passive House website or Passive House Institute website. You search for MVHR and you can see that all the units that comply to passive house standards. So the example there on the right is an Airflow MVHR unit. And to meet the passive house standards, the thermal efficiency needs to be above 75%. So that's higher than the standard building regs. So the building regs stated 70%. But if you want to build a passive house, you need an MVHR that can achieve 75% or higher. The SFP, the specific fan power, must be lower than 1.62. You need to have high grade filters in the units. So G4, which is an ISO course, and an F7, which is an ISO EPM1 or EPM 2.5. So these, they require higher filter grades on the supply side to ensure the fresh air, that the supply air going into the dwelling is filtered to a much higher standard. The MVHR also needs to be frost protected, has to have an air tightness and insulation with an air leakage less than 3%. You also need to be able to balance and adjust the supply and extract air volumes. So there's a link there for more details on Passive House. So going on to now how heat recovery works. So this is showing a plate heat exchanger, which is crossing over. So it's a counter cross flow heat exchanger. So this works by extracting the air from the dwelling. The stale polluted extract air is put out into the atmosphere, and the warm air is stored inside the separating fins of the heat exchanger. Then when the air is brought in from outside, it crosses over the heat exchanger. It's heated up by the stored hot energy inside the heat exchanger, and then it's supplied into the dwelling. This is an anatomy of a heat recovery unit. So on the left there, you've got what the unit looks like when it's all closed up. So just like a standard white goods appliance to go in the home. And these can be installed anywhere in the home, ideally in the heated envelope of the building, in the utility room. So the middle image here shows you the inside of the unit. The image right in the middle is the counter crossflow heat exchanger. So this could be made of aluminium or polypropylene, and they tend to achieve efficiencies, heat recovery efficiencies up to 95%. Importantly, they also have a summer bypass to help with Part O overheating. So this makes sure in the summertime, it's an automatic system. It will bypass the heat recovery when the temperature's reached a certain point, so that it's not recovering the heat in the summertime, and it's just supplying fresh air into the dwelling. So this gives a form of free cooling in the summer. You have a condensate drain underneath the heat recovery heat exchanger, because when the hot and cold air is crossing over, it does form some condensates, and this needs to be drained out of the unit. There's an intelligent frost protection on this unit with built-in temperature sensors. There's energy efficiency EC fans. So there's 2 fans, a supply fan and an extract fan. These give very low SFPs to meet Part L. You've got high-grade filters in these units. So again, the ISO EPM1 F7 pollen filters on the supply side. This meets ISO 16890. You've got digital controllers that can be supplied with the unit. They also have an internet connection. So the units can be connected up to the internet, and they can be remotely accessed from anywhere. Of course, they'll be password protected. The pre-filter would be an ISO course, G4. You can also have these units with built-in electric heaters as an option, and built-in CO2 sensors. So these come as standard with these models, not with every model on the market, but if you have a CO2 sensor built in, then the ventilation rate will run automatically according to the CO2 levels. Then finally, the unit casing is constructed from galvanized steel, powder coated, double skinned with 20 mil insulation. So this means there'll be no thermal bridging. Just on the controls, they can come with manual user controls. So the MVHR units can come with options of basic control or digital controllers. And some of the settings available are home, away, boost, and fireplace. So home would mean when the dwelling's occupied, you'd have the ventilation system running on the home setting. Away, of course, is when the dwelling's unoccupied. Boost would be when you'd want to increase the ventilation rate, when perhaps you're having a party or you've got people around, so when the occupancy has increased. And fireplace is selected when you're using or making a fire or using any of the gas appliances. So I mentioned the internet connectivity. So Not every unit comes with this option, but it is an option on the market. So you can have a unit, an MVHR unit with internet connectivity, and obviously the benefits are that you've got that remote user control, so you can access it from anywhere on your phone, your tablet, your laptop, and you just need the IP address of the unit. Like I said, it is password protected, so only you can access it, the homeowner. You're able to get quicker remote diagnostics. It's also an advantage for the manufacturer, because if the unit did incorporate a fault, you wouldn't necessarily need to have an engineer call out. We would be able to access the unit from the factory and be able to diagnose the issue there and then. So you'd get a quicker diagnostic, and it would save sending an engineer to the site. So going on to the filters, I mentioned them just then when we were going through the anatomy of the units. So all MVHR units, they come as standard with a minimum of 2 filters, one on the extract, one on the supply, and these must be ISO 16890 compliant. The minimum grades are ISO coarse, which are the most common. These are okay on the extract side, but you should have a minimum of ISO EPM 2.5 or EPM 1, which is also known as an F7 grade pollen filter on the supply. So to filter the air into the building to a higher standard and improve indoor air quality. So some of the common filter standards and grades that you'll come across is the ISO coarse, which is G4, EPM 10, which is M5, EPM 2.5 and EPM 1 F7, EPM 1 70%, which would be an F8, and EPM 1 80%, which would be an F9 filter. So these are some of the most common filters on the on domestic heat recovery systems. And then other types of filters that you also may come across and that are available include things like nitrogen dioxide filters, NOx filters. So these filter particulate matter and gases, and they remove pollutants prior to the air entering into buildings. These filter up to 90% of harmful NOx particles out of the incoming air. There are also options to have UVC filters and ion generators, which are bipolar ionization. And then just to talk briefly about that, so the ion generators, they are particularly relevant at the moment, because these can filter out things such as virus and bacteria cells. So they reduce and remove harmful airborne virus and bacteria cells via the ventilation system. The ion generators, they produce natural bioclimate rich in positive and negative oxygen ions, and they neutralize particulate matter, bacteria and virus cells, gases and VOCs. So this type of technology actually outperforms PCO, photocatalytic oxidization, and UV, ultraviolet, and HEPA filters, because they have a lower pressure drop and less energy consumption. And they're also ozone free. So we're coming towards the end of the CPD now. Just going to briefly talk about the ducting system, because this is equally important when you're installing an MVHR system to get it right. So when investing in an energy efficient MVHR unit, you do not want to lose the benefits gained through another part of the system. Improvements to indoor air quality can also be significantly compromised by leakage from a poor quality and badly installed ductwork system. And unfortunately, this is all too common. You'll see some examples below of some poor installations here. And there's a number of issues if you don't get the ducting system right. Part F, Volume 1, it refers to the duct connections, and that says they should be both mechanically secured and adequately sealed to prevent leaks. Rigid connectors and Jubilee clips should be used for flexible ducting to ensure a good seal, because if that ducting starts leaking, it increases the pressure of the ventilation system and reduces the performance. So there is a mention of semi-rigid ducting, and semi-rigid ducting is known to be the most effective form of ducting to be used with a ventilation system. It's quick and easy to install. It's flexible, and you can bend the ducting and it doesn't crush like flexible ducting. There's zero air leakage. They are hygienic types of ducting systems. They've got an anti-static coating, so it means there's no dust and dirt buildup in the duct system. There's no loss in pressure, and there's no noise transmission. So semi-rigid ducting performance data is recognised by the UK government as an input for SAP calculations, Appendix Q, and again this system can be found on the PCDB database. Just search for semi-rigid ducting. Finishing here with airflow testing and system commissioning. So demonstrating compliance for each dwelling is the installer's obligation, with data supplied to the relevant building control body. And now also, as we mentioned earlier in the presentation, the homeowner, occupier of the dwelling, must be provided with commissioning details and a home user guide for their ventilation system. So we've got a reference to NIC EIC here. So user trained and registered installer approved by the NIC EIC competent persons ventilation installer scheme. They will have been trained to install these types of systems, and it's important to get them tested once installed as well to check that the ventilation systems are running. And you will know that if your ventilation system has been checked, because you will have been supplied with the commissioning details, which would detail the performance of the ventilation systems. Just to finish with some example projects here. So there's Blackrock Street in 1 Manchester. This was to Passive House standards. Queens Hill Avenue in Leeds, London Borough of Ealing. We've got Alpha Square in Canary Wharf, Springfield Meadows in Oxford, and 1 Thames City, 9 Elms. So these are some example residential properties which have got MVHR systems in place, and they also utilize the semi-rigid ducting systems. Thanks very much for listening, and we'll now take any questions.
Thank you so much, Ian, for such an in-depth presentation. So now I would like to bring everyone to the Q&A session. If you do have any question, please do use the Q&A button down below on Zoom. But I do also got quite a few questions here for you, Ian. With the MVHR unit, what is the minimum footprint of the house? Say, you know, for the residential unit, what's the minimum would be suitable for those MVHR unit, and would it be suitable for an own home if it hasn't been done or, you know, retrofit just yet?
There's not really a minimum, to be honest with you. We can supply MVHR systems for a 1-bed apartment, and right up to larger properties with 5, 6, 7 bedrooms. It's all worked out based on the floor area, but also based on the number of bedrooms. As you saw in the presentation, it gives minimum ventilation rates for each number of bedrooms. So we'd work out the number of bedrooms, number of occupants, or potential number of occupants, and also the floor area of the building to decide on what the best ventilation system is. And I know you mentioned there are existing buildings as well. So with existing buildings, there also is an MVHR system available that can be ducted through can be installed directly through the wall, so that you don't have to have ducting systems running through the home, because on existing buildings it's a lot more difficult to get all that ducting installed. It's much more easier when you're building a new home to put a MVHR system in with the ducting. So there are solutions for retrofit as well.
But is that compensate with the heat loss with the existing building?
So that would reduce the heat loss. If you put an MVHR system into an existing dwelling, it will reduce the heat loss. So they are designed, these through the wall heat recovery systems. They'll be continuously running. They tend to be installed as a pair. So one would be running at supply, the other would be running at extract. And whilst one of them is extracting, it would be storing the hot air which has been built up inside the dwelling. And then every 60 seconds they alternate. So then that would switch to supply, and then it would blow that warm air back into the building. So reducing any potential heat losses.
Brilliant. And we also got quite a few questions here. What service zone would you need in a ceiling for the distribution of ductwork, and what size should be allowed for the MVHR unit itself?
So in the ceiling, the ducting, if we refer to semi-rigid ducting, that is 75mm diameter, and then these can then connect to distribution boxes, which could be up to sort of a maximum of around 200mm in depth. So potentially 200mm, but it depends on the size of the system, the size of the dwelling, as to the size of the equipment. The MVHR system itself ideally would sit down in your utility room, and again, depending on the amount of ventilation that needs to be provided to the dwelling, it all depends on the size of the unit itself. So it could be the size of sort of a very small box, or it could be the size of, a sort of, comparing it to other appliances, similar to like the size of a washing machine, dishwasher. But if we're then talking about a larger property with sort of 5-6 beds, bedrooms, it could be a much larger unit because it needs to move a lot more air around the building.
Right. So I assume that is potentially could go into the loft space. Following the question.
Ideally not,
No.
because
Okay.
because as a manufacturer, we recommend they are installed in the heated envelope of the building, because in the loft space there's a lot more heat loss. So it can also be a lot more difficult to maintain the units up there. They could be forgotten about because they're out of sight, out of mind. But if you're worried about space, there is also options to have MVHR units installed above your cooker hob. So they could actually sit, instead of your kitchen extract hood, you could completely take that out, and you could have a full MVHR unit sitting above your hob, and that can do the whole dwelling ventilation as well as extract from the hob. So there is systems that we can provide for that.
So you mentioned because MVHR also suitable for, say 1-bedroom flat. So means that in terms of the maintenance, can the resident actually do it ourselves?
Yeah. I mean, the main maintenance that you'd have to do on an MVHR system is changing the filters, and depending on the location of your building. So if you are out in the countryside in the nice sort of what we call clean, fresh air, the filter replacements will be maybe once a year, if that. Whereas if you're in a sort of busy city centre, the air pollution is a lot higher, so the filters will get dirtier a lot quicker. So you may then have to replace them 2 to 3 times a year. But the units do tell you when the filters need replacing, and you can do a visual inspection of the units to see when the filters need changing.
Okay, so that's now easy enough. Can we touch on a bit on the cost then?
Yes. I mean, I can't really give you a cost because every single property would be different.
Yeah.
And it
Does that
depends.
be like roughly per square meter, say, if we want to, you know, apply the MVHR unit and install it in the home?
Yeah. So because I don't work for an installer, so I don't know the install costs, to be honest with you. So I can't give you the install cost, but a rough cost of the system as a ventilation system could vary depending on how good a quality unit you want, because there is basic entry level MVHR units on the market. And there are highly efficient heat recovery units on the market with intelligent controls. So the costs could vary, say from £2,000 up to £10,000, depending on your budget, depending on what capabilities you want the units to do, depending on the type of ducting that you use. So yeah, it does really vary. So I'd say if you're looking to get a rough estimate, speak to the manufacturers, and they'll be able to help. Usually it's we tend to ask for the drawings so that we can look at the size of the buildings, work out the occupancies, and then give a rough estimate on the size of the MVHR unit that they'll need, and along with the ducting and accessories.
That's a good news though. At least it's now a bit more accessible.
Yes, yeah, no, exactly. Yeah. So, and what you have to think about is, yes, although the cost to buy and install a system initially may seem high, in the years to come, it will save you money, especially on your heating bills. But what's more important is not really the cost saving, because yes, everybody, when they hear heat recovery, they say, oh yeah, okay, well, I'm saving money on my heat, great. But what people don't tend to think of straight away is the air quality. So having an MVHR system will dramatically improve your indoor air quality in your home. So that is the main reason why you'd want to go with an MVHR system, especially with the higher grade filters, because yes, if you have got people that live in your dwelling, or you've got friends or family that come over that maybe suffer from allergies, asthmas, or even just hay fever, if they've got the right ventilation system in place, it completely solves those sort of health issues.
Yeah, of course. And we only got about 5 minutes left. Do you want to leave the audience with all the do's and don'ts? I know that you already gone through some of them, but is there anything in particular that, you know, before you consider install any ventilation unit, what else you need to really consider?
Yeah, I mean, the main ones would be to, once the unit's installed, make sure that it is achieving what it needs to achieve, so at least the minimum rates. But remember the rates that I covered in the presentation, and what are stated in the building regs are just the minimum rates. So you can have a system to do more than that, and it's recommended that you don't just run the units at their minimum rate all the time, because then you are just getting the minimum ventilation. But yeah, it is important to have an approved installer put the system in your home, to get the MVHR unit correct, to get the ducting and insulation correct as well, because it is the installs that sometimes let these systems down in terms of the performance.
That's really, really important. Thank you so much, Ian. And this is what we have time for today. And I would like to thank Ian again for the contribution and all the in-depth presentation today, and also the audience who joining us today. And have a lovely day.
Great.
Hopefully
Thanks
see you
first.
later.
Thanks.
Thanks
Bye-bye.
so much, Ian. Bye now.